guys, welcome to a new stream. It's been a while, it's been like a month I think since the 100th anniversary stream. Kind of 100. Let's turn the music down a little bit. Something like this? I don't know, let's see. I did tweak the ducking and attack settings a little bit, so hopefully the music is less disturbing. How's everyone doing? Let's see who's here. Chardo was first with Hi All, and then Nigel Young, both here often. A Foxhound, well, sounds new to me, but welcome. And then Draadstal, he says music. Oh, time to get started. Well, that was me. Timothy is glad for a stream. I'm glad to be back too. And John Koester and Patrick Reinhardt. Welcome all. Well, let's wait for people to come in. Oh, Philip is here, but he has a sick emoji. What's going on, Philip? Kona is here. Hey there. Morning all from New Zealand. Nice. Oh, you got a Bamboo Labs A1. Didn't you already have an X1 Carbon? Oh, speaking of, I still have a print on there from a day ago. Never took it off. Oh well. Welcome everyone. Anyone else already getting started on their holiday LED projects? I'm preparing for you guys to get started with it. Oh, maybe in the near future. Oh, I thought you already had an X1 Carbon, Draadstal. Oh, Kitty is here. Hi. Meow. Hi. Do you want to say hello, Kitty? Hold on. Kitty? I'm gonna pick him up. He's probably not gonna like that. Kitty, kom eens. Hey, kom eens. Go. Hier. Kitty on the stream. Hi. Je moet hier kijken, Kitty. Hierboven. Kitty, hier. He's very confused. Oh, here. Kitty. Hi. Yeah. You're getting a lot of hair on my... Why are you always shedding? Kitty? Yeah, you need to knorr into the microphone. Purr into the mic. Mic is here. Oh. Yeah. Are you a stream kitty now? Oh yes, very nice microphone. Yes. Oh. Why are you drooling on me? Stop drooling. Here's your drool. Okay. Go back down. Okay. Now I need to clean my desk because now there's cat hair everywhere. Oh. Yeah. Good kitty. You drool a bit much, but okay. One moment. I'll be right back. Come on.
Not one to run, but I can't just hang around.
The weirdest pre-stream? What do you mean you didn't like seeing Kitty? I thought like showing Kitty would give me like lots of stream points. My channel go viral. All this hair. The cats are always very surprised when they know they've been on my desk when I wasn't there. And they're like, how do you know? And I'm like, there's a gazillion amounts of hair on my desk suddenly that wasn't there yesterday. Hey there, Foxhound. Okay, I think I got most of it. Should have gotten one of those rollers. Kitty, for some reason, is always shedding hair. I don't know how he does it, but... Okay. That should do it. Hello. So, what's everyone drinking today? Weirdest pre-streams. Well, would you rather me not show Kitty, Philip? We have some drinks that were brought by two friends. And so, let's take a look at those. First, we have a drink from Germany. It's Fanta Zero Sugar, but in a 330 milliliter can. We always get 250. And then pineapple grapefruit. I don't think we have that taste here in the Netherlands. And then we have some Coca-Cola Zero Sugar K-Wave. Let's hope it's better than the AI one. And then we have Coca-Cola Zero Sugar Oreo. What? What? Fizzy cookie flavored. I don't know, man. I've already had this one. It's pretty good. I like it. I don't know about this one. I'm a bit afraid to try it after the AI disaster. That's right, Philip. A rebranded little product? I don't know. I've had more of these too, and they're also pretty good. So, yeah. Anyway, nothing like drinking cookies. Exactly. A long G&T. Ooh, fancy. Foxhound's drinking water. Oh, that's fine. Lilt. I don't know what lilt is. Fizzy cookie flavor, exactly. And we just had wet, no, not wet, it wasn't wet, hairy pussy on the desk, so I don't know, man, what this stream is going to be about. Who knows? Who knows? You're about to go get some lunch and beer. Nice. I don't drink beer myself, but if you like it, it's good. You will stick to the real Coca-Cola. Yeah, sure. Oh, wow, really? Okay, interesting, Medved. Philip's going back to bed. It's getting weird here. Oh, I hope you feel better. I didn't know you were sick. Is this a soda stream? Could be. Who knows? No, we do have to build stuff today. You like the LED lights behind me? Yeah, thank you. They are 144 LEDs a meter, WS28 15s, and they are on the saw pattern and doing random colors. Now would be a good time for an ad. No, I promoted like Fanta and Coca-Cola and everything, so no need for an ad. I already promoted stuff. Hey Rob. Yeah, my sleeping times can be weird. It varies all over the place. The short. Were you doom scrolling, Philip? Were you doom scrolling on the shorts? And this Quinled LED stream is brought to you by Fanta. No, but we are going to try some new Chinese stuff. This is from a Quinn box that hasn't been released yet. Normally I have my chip quick stuff and everything like that, but it's getting a bit old. And I was like browsing AliExpress like I always do. And I found this guy, which is soldering paste, lead free, but it is 138C, so it's low temp paste like I like. And well, it's from the AliExpresses. So we're going to give that a try today, see how well we like that. I also got some in a tube, which is also 138C, so also low temp. Same composition basically. And then I got some how do you call that, resin or flux, but I'm not sure I'm going to use this because it says, warning, this product has slight conductivity. I guess you can show you guys too. Slight conductivity. If used after cleaning the circuit board, please make sure to wipe it clean. What? So if you use this after cleaning, you need to wipe it clean. Okay. Prevent short circuit. So I flux that is conductive, not that great. Not that great, so we might not use this. But yeah. So we'll use the new paste today, see how well it does. Gotta use it at some point. And for board, we have the following. We have a test board. Whoa. Come on. And a stencil. Let me unpack the stencil real quick. No. Where I am from the Netherlands in Europe. I couldn't see the tape here. Hold on. There. Okay, so we have our stencil. Good. And we have our PCB. Is this the one I already touched all over? There will be upcoming news about the house, but it's not finalized yet, so no news yet. Okay, let me get my board out. Well, the last thing we sold, it was really tiny. Oh, look. There's a little garage spider. Come on, buddy. You know the deal. You're allowed to live in my house as long as I don't see you. If I do see you, you didn't obey the rules. Thanks there, Pinball Compy. Maybe that should have been company, I don't know. Awesome VR6 Synchro. How's the weather? Cold and gloomy. Where's my PCB? Let me get a new one, because I think I touched this one all over. I don't want one that has fat on it, or grease. How's the stencil laid out? I can do it like this. Okay. So we jam that in there. Oh no, Quinsense, if anything is coming with that, is going to be very far away. So I would spend your voucher there, Alexander. In the coming month, I hope to release another analog board, but that's it. So if you're waiting on other stuff, yeah. Let's see, this should go something like this. Now I need to hang in front of the camera for just a second. Damn, I think I got it. Right? Good. Yeah, that should go on nicely. 80. Well, if that's centigrade, you're gonna die. Where is my package with boards of shame? What? What do you mean, Philip? Kitty should do a better job of removing the spiders. Yeah, maybe. We have a new kitten, though. And that is chasing everything in the house. So, also the flies, which is good. If we ever have flies, she'll eat them. I like that. Okay, let's take a look at our jar. Discovered your website yesterday. Can't wait for the pre-built Deca. Cool. Yeah, the AN Penta Mini is out, and the AN Penta Plus will be next because we had some production issues with the Deca. But that will come pretty soon after that. No, the black one is Evie. We have 3. So, Evie lives upstairs and doesn't like other cats or humans. Oh man, how am I gonna open this? I always hate these things. I guess I should puncture it, but I'd rather pull it off as a whole. Yeah, I don't think they'll make that possible, huh? Because then there would have been a lip. Yeah. But then I'll smear all the paste over it. I'd rather actually remove it. So maybe I... Okay, now let's try something here. Okay, I need to move this. There. So I do... Oh no, there's already paste. And then I try to get it up. Yep, paste on my scissors. Okay, and now I try to remove it. It's very gooey. That's good. Let me get some tissue paper. Thanks, Buller. So let's get this on there. I don't want to touch it. Okay. Let's see if we can get the rest pulled off. Well, close enough, I'd say. Right? So there shouldn't be too much stuck to it. So now I need to clean my fingers and my scissors. Oh yeah, we also put lots of stuff in the dishwasher. We recently put the cat flap in the dishwasher. It worked out great. Okay, so now we got our gooey mess. Oh wait, clean the scissors. Okay. Is the pasta tasty? Well, I'm not gonna taste it, so we won't find out this stream. It's not very smelly, so that's good. So now I'm just gonna goop a little bit like this. Well, maybe I should mix it a little bit. I'll mix it a little bit. Okay, so we're going to take a nice glob here. It's very viscous. More so than I'm used to. So let's see if we can get some of it back in the pot. Okay, most of it's back in the pot. Okay, so now we're going to ball it up. Yeah, I've stirred paste or flux in before. This is more gooey than I'm used to, so let's give it a try. I kind of want to do it one more. No, I think it even got the tiny little ones over there. It's a bit too gooey. But looking at the result, that's not too bad. There's no paste there, that's correct, because it's a solder jumper. Yeah, I think it got everything. Top left. No, you mean here? Yeah, no, that's a solder jumper, so that's fine. Yeah, no, it looks good. I'll take it. So let's get the excess off. See what I mean by that it's very gooey? Wow. That's a bit too gooey for my liking. Oh man. Okay, got most of it. Yeah, okay. So let's try and clean this up a little bit. What flux? I generally have flux from Chipquik, which is pretty good. Okay, let's seal this jar before it goes everywhere. Okay. So. MG Chemical, okay. I've never used that before. I've used different kinds of fluxes. I usually have my stuff from Chipquik, which I like, but I thought, like, okay, sometimes I like to recommend stuff from AliExpress. But then, if I want to recommend it, I have to try it first myself. So, that's my kind of my rule. Man, let's try and clean this up. Well, I guess it wipes off okay, from the stencil at least. We'll see how it is to work with and how well it actually solders in the end. So far the viscosity is a little bit too fluid. Okay. Good. Let's put the stencil back. And get an onderzetter. There. You can see the burn marks. It's being used often. Okay, let's turn that around. My new logo on there. So this one has 4 different circuits. 3 of them are SEPIC converters, and 1 of them is a buck converter. Sure, yeah. I don't actually know if this one says it needs to be refrigerated. Causes damage to organs through prolonged or repeated exposure. Causes serious eye irritation. Full safety information on datasheet. Okay. JPT solder. It doesn't actually say if it needs to be refrigerated or not. Maybe. So let's get you guys zoomed in. There's lots of components, but a lot of them are shared, so I'm hoping it won't take too long. Let's get the file. How do I do this again? Oh, I'll do it over here, I think. And then I zoom in the text. And let's share a window. So that's too big. Now we don't need... Oh, no. Let's not do that. We don't need... No, also not. There, that's what I need. We don't need this part. No, other way. Let's try it this way. It's a bit small, I guess. I guess we only need to see the components. There. Now you can, I think you can still read what component we're working on and where it should be, right? What is the goal of the board? Well, it has 3 different SEPIC converters on there, mainly with different inductors. I have an LDO that I want to test on there, and I have a buck converter that I also want to test on there. All with specific loads and goals in mind. And I want to test various responses with various inductors and brands and slight resistor variations, slight capacitor variations, things like that. And sometimes the only way to do that is by building it and testing it. So I should have most of the components next to my desk already, because I was checking if I had stock and I was like, oh, let's separate these in another pile. So let's clean these. Okay. Let's see. We need 1206 2.2 UF 100 volt. And of course, it's at the bottom. Because where else would it be? Oh, no. Okay. Well, you can transmit over a gigabit network, but wouldn't do you much good. So we need 20 of these. Holy shit. 100 volt, 2.2 UF, 1206. Yeah. I'm just going to do a whole bunch on my desk here, and then we'll just start placing them. Now that I'm doing this, I'm thinking maybe I should start with the 0402s. We'll finish these and then we'll go to 0402s. Well, with the paste being so viscous, the components do stick well to it. Oh. Yeah, we should really move to 0402s after this. Go from the smallest to the larger components, because otherwise it's never going to fit. Or, well, I won't be able to make it fit. Okay, 3 more. These are titanium tweezers. And I think if you go to Quinled.info and you scroll down, you go to the tools and equipment list. I believe they're in there. Okay, so now we have these done. Okay, I need to adjust the settings. Placed. Oh. Yes. Okay, so we're going to change strategy here, and we're going to move to the smallest items first. So we'll need this box again later, but let's see, capacitor 0402 I think we need. So let's see, yeah, we need 0.1 UFs 0402s, so let's do those. Well, how many volts? 50 volts? Yeah. X5R. Okay. We need 5. Whoa, these are small compared to what we just did. So let's see where this goes. Okay. Come on, let's go. Okay. We'll have to check those with the microscope later. I'm gonna need to turn this because otherwise I won't be able to get it. Okay. Oh. So I got that one. I got that one. Ah, this one needs 2. Okay. Okay. Those are done. Let's see, whatever other 2.2 UF. Okay. Yeah, the Discord is a lot easier in that regard. Let's see, 2.2. This is 10. 22. Okay. So now it's on to resistors, since those are the next smallest thing. Let's see. Might have to get those from a different box. Do I have 20K? Yeah, I do have 20K. Nice. Okay, I need 4. Yeah, steady hand helps, although part of it is technique. Let's see, where does this one go? Over there. Because I most of the things I'm laying with 2 hands, because it's much more stable than 1. So this one goes here. You kind of want to prevent that your hand is floating in the air. So you want to stabilize it as much as you can. There. But what I'm doing is I'm resting my hand on my palm, so I'm only doing this motion. It's not my... You need to make sure your arm isn't floating in the air, but this is resting, so you only have to do this. And then with my other hand, I often still stabilize here or here or here, so that I'm actually only doing this. And that makes it a lot more stable than having to balance all those muscles, basically. Let's see. Do we have more 0402s? Yes, we do. 51K. 56. 56. 51. Yes, I have a 10 by 10 hot plate and I have a 20 by 20 hot plate. But this should do fine on the 10 by 10, I think. Also because I don't need very high temperatures. Yeah, should be fine. 51K. Sorry that the camera is missing focus. I can try and adjust that. Because it's focusing on my hand and not on where we want it to focus. There. Let's try that. Yeah, that's better. Okay. So that's 3. Good. Oh, here's another one. Okay. Damn it. Must have named that one slightly different and then it comes up as its own item. This board is 4-layer. It's 4 layers of 1 LZ. So we got that one. So now comes some interesting values. I might need to dig around in a box for that. 28.65, huh? Yeah, I need to dig around in a box for that with new components. Wonder where I left it. Hold on. I think it's over here. No, this is not. Where did I put my new components? Uh-oh. Would have been logical to put it somewhere here. I didn't prepare this part. Uh-oh. It's not in there. One moment, please. Okay, I got it. I got the box. So 28.65. Let's see if we have that. Of course, these are not numbered. We'll need this later. We won't need this later. We'll need to research all the packets which has resistor. Yeah, I should have labeled these already. Oh well. One moment, please. These can go here. That resistor should be in here. Oh, holy! SF Anytime sends in 200 NOx. What's that? Norwegian crowns? Looking for some individually addressable LED strip. Want to put an LED down, a light down of the floorboards and ceiling boards on the TV wall. Length is about 4 meters to 4.6. Want to connect it to WLED and they work together. LED down with the floorboards and ceiling boards on the TV wall. Okay. Well, you could go for a Dig Uno, which will give you 2 outputs. While we talk about this, I'm going to research what my baggies are. So you can go for a Dig Uno, which gives you 2 outputs, but it only has a single power output, or fuse rather. And it's better to have multiple fuses. So if you want to do the top and the bottom, I'd recommend going for Dig Quad. And then if you're just looking for RGB effects, you can go with 5 volt, depending on wire length. And if you can easily wire it up, so just some WS2812B, or maybe if you like some Y2, some SK6812. Or if you don't have the space to do a lot of wiring, you can go 12 volt. And then WS2815 is often a good option. 15.8, okay. Yeah, I'd say those are the things to start looking at. 16.5. I need to print labels. Hold on. 15.8. Hold on. No. Oh, 402. 50 volt. I better label it correctly now, because otherwise I won't later or have to do it again. 15.81%. Yes. So I label all my baggies like that, so that I know exactly what's in there at a glance. Because otherwise, I have a hell of a time finding it when I need it. Uh, 16.5. Yeah, 5 volt is okay. It's most efficient, but you need to be able to do the wiring. If you're not able to do the wiring easily, best to start with 12 volt, or if you go cob, just go straight to the 24 volt. .7. I think that's the one we need. Oh god, which one was it? 7.2. This one. Okay, one more baggie and then I'm done for now. Ah, okay, this is something different. Don't need that right now. Okay. Where's my streaming window? Here it is. Good. Yeah, 2815 is inefficient, but it is much easier to wire, or a bit easier to wire up. So yeah. So we need 328.65, which became 28.7. That's fine. And let's get it out of the tape. First one doesn't want to come out, okay? There. Let's see where these need to go. They need to go over here. Sorry you can't see right now, but it should fix itself. One over here. One there. And one there. Okay, now we need 16.4. I think that's another... Yes, I've got 16.5 here. Oh, I only need one. Wow. These resistors, together with the 51K, they determine the output voltage of the circuit. And if you remember the last stream we did where we built stuff, we built a prototype for a dig to go, or a dig to analog plus, and it didn't work. But I fixed it quickly after stream because I indeed had specified the wrong resistor, and replacing it with the right resistor actually fixed it immediately. Now, after testing that design, I've decided to put in some more work and change some stuff of it. So that project is a little bit on the back burner right now. We already have the dig to analog, and the actual analog boards are coming out, so... But it would be nice to have in the future. I think that is most of the 0402s. So let's move on to 0603. Yeah. So we have two. Okay. So this can go here. This can go here. I need more wire. There. 0603. Capacitors? Yes. Don's from NZ. So, oh, my mouse moved. 10 UF. Oh, 0.1? 100 volt. I hope I got those. Let's see. 10 UF 16 volts. 10 UF 25 volts. That's fine. And 4. Okay. These are for the output capacitors. Okay. Now this is going to be interesting if I have these or I need to go look for them. 50 volts. 50 volts. Oh, here we go. Well, 603, 100 volt, 0.1 UF. Or 100 NF, that's the same thing. So. Eight. Okay. Okay. One goes here. Come on, let go. Oh, wait, that's wrong. There. Okay, now we're moving up. We're moving. Oh, wait, I need to put this back in the thingy. Oh, I don't even look at the labels on the board, to be honest. Often I also take those off, but since this isn't a production board, it doesn't need any nice silk screen or something like that, so I did orient them a little bit so they'd be readable, but let's see, 22 UF 0805, 22 UF, how much volts? 25, got them. 11. I didn't count. I think this is about 11. Okay, so these are part of the outputs again. And as I mentioned, I'm going to test all the circuits with all the components on there first. And then later, I'll likely take off some capacitors and things like that to see if those are actually beneficial or not. I do like to over-design my stuff, so I often err on the going with too much capacitance instead of too little. Come on. Before we reflow this, we'll look at it under the microscope and correct everything. Let's see, I think I got them all. Yep. Okay, we're starting to get there. So then we need these, I'll do that later. Oh, we need some 1210s. I think that's the same box here. 4.7, 12, 10, huh? No, no, 22, no. That's wrong. What's going on? Okay, let me. Oh, wait, oh, there should be over here. 4.7, 100 volts, okay. We need 3. Oh, Yucko's here. Welcome. So these are big ass capacitors. Oh. Okay. So let's scroll down a little bit. Inductors. Okay, let's do these Zeners. Because those are very tiny. That's these. Tiny mothers. Mother effers. Oh, and these have polarity too. Hold on. Whoa. Need to use the so pin 1. Can I see the stripes? Hold on. Okay, so the stripe goes in the box. So I look at the orientation with my magnifying glass, and then I place it like so. Let's go to the next one. That's this one. With these, if you sneeze, it suddenly turned around. Okay. Well, I know where the other one goes. Okay. That's one of the tiniest things that was left. Let's do some diodes. Those aren't big, but they're a bit bigger. Oh, I don't have the box here, I think. Let's see. Oh, it's right here. I need 8. Sorry if this is boring. I don't actually know. People often say they like watching me build PCBs, but it's a bit boring subject, I guess. Because I can't really pay attention to chat a lot, because then it takes way too long. So yeah. Later, Foxhound. Thanks for joining. Okay, so let's zoom out. Right. Right. Oh, okay. I don't think I've ever smoked the Zener. I'm not sure. How did you smoke it? Did you overheat it? I think that's all of them. You put the LED driver in backwards. Oh, yeah. Doesn't like that. Let's do these tiny, tiny inductors. I need to get those out of my new box. Or maybe they're over here, but... these are okay. Yeah, okay. These are those. It's kind of zen when then it's not your board that goes up in smoke. When it doesn't work. I'm pretty confident these will work, but you never know. You could always get a bridge where you don't expect it. Hey, and we have the mystery solder paste, so... I always like paper tape with plastic on it better than plastic tape. It's horrible getting the tape off of it. Okay, so these are actually tiny, tiny inductors. Now I need to see if they have a pin 1. In theory they do. But I can't find it, so no pin 1 for you. Okay, then that one goes over there. Looks like I got that footprint pretty good. That is these three. Then let's place these. I need 4. These will provide a little bit of input filtering. Right, I said I need 4 and I got 3. Okay. Don't forget to include the magic smoke. Yes, all of these components come complementary with Chinese magic smoke. So if you do your best, they'll release it. So, with a buck converter, in my opinion, I'm going to start a drink. In my opinion, with a buck converter, if you fuse the input side, you're kind of okay already, unless you're talking like a 20 amp buck converter, then you might need to protect the wires behind it. But you kind of protect for wires. So if your wires after the buck converter can handle the 5 or 10 amp or whatever the buck converter can put out, as long as you have a fuse on the input of the buck converter and it's protecting that wire, well, if you can't overload the input, it'll burn the fuse. You can't really overload the output either. So as long as the output wire is rated for the current of the buck converter, I don't see the need to additionally fuse the output side also. You can, it's no problem, but yeah. Oh, pineapple-y. Pineapple-y. Pineapple-y in my nose. So let's go for the other size inductors. Which is a bad plan because I still need to place other stuff, but you know. Yeah. No. Yes. Okay. I think those are these, but I'm going to check. No, I want to use this one, I think. Yeah, I want to use this one for this round. I don't want to use this one. Okay. Say 5 buck converters to a single max power output 20 amp circuit? How do you mean? They can't output to the same thing. So we're going to do these first. Okay. Let's see where these are. Okay. And then we go one step higher. Yeah, if you're running buck converters in parallel, it depends how you're doing it. If you're running them very close to each other, that's bad. You shouldn't do that, just the same with two power supplies. But if you're doing it to combat voltage drop, you basically already have a lot of resistance or voltage drop in between them, and thus that's fine to do. Because even if one would fail, the other suddenly won't have to deliver double because it can't, because of the voltage drop which you're trying to solve, right? So if it can only deliver 5 amps to the strip, and the strip doesn't take in anymore because of voltage drop, and you then go 5 meters further and do another 5 amps, if one of those would fail, it doesn't suddenly deliver twice the output, because, well, the resistance that you were trying to fix in the first place is still there. So that will prevent overloading that buck converter, basically. Now I need to see if I need to actually turn these around. No, good. Distributed 10 meters apart. Yeah, so then the resistance of the strip or the string or whatever will prevent overloading the output side of that buck converter anyway, because of the exact problem you're trying to combat. Like, you can't distribute more power over the strip. So you don't have to worry that a 10 amp buck converter in that place suddenly is asked 20 amps, because, well, the wire can't deliver that. So, yeah. Right. Let's start placing the actual ICs. Should have those here, I think. Buck boost converters. Which do I need? Yes. I guess. Okay. Oh, I'm sorry. I did not realize. My bad. Thank you, Edward. Oh, this is a 6 leg. Okay. Then I need to watch out where pin 1 is. Okay, that's one down. Need 3 of these. These are 5-pin, so that's a bit easier. Other way around. No. It jumped away, but I got it. Jesus, sometimes they just don't want to lie on their face and only on the back. Okay, good, 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 good. Let's put those here. So now we need one of the new things. So I need this box again. Okay. Also done. We're getting there. Let's see. We need some PTCs. Sure, these will do. Pepsi is here. Sadly, I only have Coca-Cola today. And some Fanta, but, you know. I actually dislike Pepsi a little bit, so sorry, Pepsi. I like Coca-Cola a bit better. So these will just go here. Okay, and now we have two things left. We have the 1 watt resistors. Let's do those. But I need to find the one I want to use. Oh, they've effed up the baggy print again. So before, JLC PCB used to do this fine. So this one is a 1 watt 2512 750 milliohm. Okay, but then I have 3 other bags, and they just say whatever, whatever, and whatever. Now I can deduct that this is the 2512 750 500 250. So this will be the 1 ohm, which I need. But it's stupid. Why did they mess up their labeling so that now I can't read it anymore? Oh, I like the pineapple grapefruit actually. I already had some cans of it before. It's sweet but not too sweet, and it's nice and refreshing. Hold on, let me fix the... There. Okay.
They talk about another kind of world.
You sold the Ferris wheel. Guess we'll have to build another one. Nice. Well, it certainly looked nice. Okay, let's see. I need capacitors. I was going to say, I know I checked those. 47 100 volts. 33. 47 100 volts. And I need a third. There's 40 hours? What do you mean? Okay. Should I place these by hand? I'm not sure. I'm going to try and use my tweezers. And then once it's on, I'll hold it like that. Yeah, that works. Oh, it takes 40 hours to build a Ferris wheel. Wow. Okay. So, do we see any missing components? I don't think so. But we will check with the microscope to see if everything's in place, because if we reflow it and we get a mess during reflow, better to check it now. So I'm going to remove my board here. And let's get the microscope out. There. Let's hook it up. I'll need you guys to pay attention to see if anything is really, really crooked. HDMI. Let's turn it on. Oh wait. Turn on power. There. Okay, let's turn off the board view. Microscoper. Guess you'll be ordering some more Quinled LED projects. Well, I don't mind that. Right, so let's see where we're at. Okay, let's zoom in a bit. I need to move this PCB. Hold on, there. So let's start with the top one. Sorry. Let's move this in. Okay. So starting the path, that's fine. This diode could use a little knock like that. Okay. That's okay. That should flow. That's okay. Yeah, I mean, these are kind of... I guess I could tap it a little bit. That should flow, that's fine. Diode is correct. Inductor is fine. Yeah, so I'd say this one's good. Next one. Can tap it. There. Should be good. Oh. There. Let's go up here. This one's kind of how you doing. Okay, these resistors need a little bit of work. There. This giant capacitor here. Something like that. The big cap has a lot of paste, and so we should see during reflow if it reflows correctly. Solder bridge on these caps. Yeah, we'll have to see if it reflows correctly. I think it'll be okay. Sorry. But there's slightly too much paste. Okay, well, and this is going to be fine. So next one. Hold on, let me move this up. Where are we? This, we had, okay, so the third one, is this the third one? Yes. Okay, so that's fine. This is okay. I can knock this a little bit. Okay. That'll be okay. Oh, this resistor needs a bit of work. Okay. Oh. This cap needs to be nudged there. This has the extra circuit here. It's almost okay. There. Move the big cap, the round one from circuit 2, okay? So this is, okay, is this circuit 1? Circuit 2, oh yeah. I think it would have corrected itself, but it's neater now, so that's good. Thank you. So we just finished circuit 3. This inductor can move slightly. There. Okay, so let's go to circuit 4. I need to move the PCB up again. Okay. Is this... Yeah, stripes are in the right place, okay. Circuit 2. So let's see, this is 1, 2. This is a diode, that's fine. This diode also looks fine. Yeah, don't worry about this paste bridging. That'll correct itself during soldering. UP1 here. Where is it? That is a solder bridge. So currently it's open, so it's not active. And I can put a solder blob on it with my iron, and then it'll activate the circuit, basically. So let's finish checking this one. That they're slightly crooked like that, I mean, that'll fix itself during reflow. Especially with the amount of paste we have. And that this is bridging and stuff like that, that should fix itself during reflow, so. Okay. So at an overview, this is circuit 4, I guess we could call it. Pretty good. Circuit 3, pretty good. That'll work. Yeah. Yeah, the paste bridges, as I said, this paste is a little bit too fluid. So that's why it's spread out a little bit in the bridges, but during reflow that should fix itself. Okay. Oh, that's okay, Philip. Thanks for being here, though. Okay, let's get my 10x10 reflow plate. That's this guy. We modified during a stream. We blew out the house circuits a few times. And since our repair and modifications, it's still going strong. So, that's good. Okay, now I need to make sure I don't touch the PCB. I'm always afraid to touch it at this point. Because then all the work was for nothing. Later, Philip. Oh, this Fanta taste is pineapple grapefruit. Yeah, I like it. It's good. It's both pineapple-y and grapefruit. I mean, who would have imagined? Okay, let's turn on the hot plate. It's set to 155 degrees, but since we have 138C paste, that should be good. So let's slide on the PCB. And as you can see, it fits perfectly. We have a little bit over here. We have a little bit over there. We're already at max zoom. No, exactly. Or right after soldering. That's even worse. I've done that once or twice. I don't think it was on stream. Oh man, because you can't really reuse the board either, because it's full of molten paste and So I'll digitally enhance your view. No, wrong one. What? Where's my capture? Here, this one. So you can see the soldering happening better. And then later we'll scroll over it while it's soldering. Exactly, super digital zoom. Well, it's a 4K camera with a really good sensor and lens. So you're likely not watching it this big that it matters unless you're watching it on your TV. We're at 96 degrees. My 4K TV's looking good. Nice. Thermal camera on plate. I guess we could. No, well, we're currently in the sold. We're at 125, so I can try and quickly hold it in front of it, though. There's smoke. Flux smoke, always good. So if we take a look at the thermal camera, how do I orient this? Oh no, okay, switching radiometric range. Yeah, there's not too much to see. So we let it soak for a little bit. And then we start nudging some components. So let's check the top one. That looks pretty good. Let's try not to inhale the smoke. Yeah, exactly. Let's go to the other two. Okay, let me check. Okay, I think we've got most of it. So let's turn off the hot plate. Let's try and move it onto my onderzetter. No sudden movements, because then components could shift. And I think we're good. Hey there, Patrick. Welcome. Let's see, put this here. Let's get my microscope out again. So, let's see how well we did, huh? Oh, camera twisted. The first circuit. That looks fine. That inductor left a little ball here. That's okay. This 0402 soldered on fine. There's a little ball here too. Those balls don't matter too much though. Let's see, that's looking great. Well, this could have soldered a little bit better on this side, but I'm sure that's making contact. This IC looks good. Pin 1 is over here, that's good. Those resistors are looking fine. Now I believe this needed to be bridged anyway, but let's remove that little ball there. And let's remove this one too. Hold on. Where was I? Ow! 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 PCB still hot. Very hot. Come on. Nope. Okay, need to do it with my other hand, sorry. This little ball here is very stubborn. There. Ah! Got it. Now the little gunk. Okay, good. Nice. So that's all looking fine. There's a little bit more balls than I'm used to. Sorry, wrong circuit. I mean, this is all in the one circuit, so it's fine, really. But we can clean it up. Well, this was a tryout for this solder paste, right? So I think that's fine. Let's see the rest. Yeah, more balls. I'm not going to remove all those balls. I mean, some of them are fine. This seems to all have soldered pretty good. Normally, if you'd wash the PCB, you'd also get rid of them, but I don't really do that for prototypes. IC looks good. These inductors look fine. Next, let's see here. Okay, I'm not going to remove all those balls if they're not going to hurt anything. Or maybe this one. There. So far, nothing that would need correcting. This could have flowed a bit nicer, but it's still fine. Same here. Yeah, it's going to be fine. Okay, last circuit. Yeah, sure. Okay. Yeah, IC is looking fine. Resistors are fine. So we're seeing a little bit more balls than I'm used to with my other paste. But the reflow did do pretty good. Come on. There. Let me tap the board. And things we were scared about bridging, like I believe we had some solder paste overflowing over here, or I don't remember, maybe it was over here. Now, well, these two are connected together anyway. That's why the pads are so close, but I don't believe we have any solder bridging where we saw the paste overflowing. That means there's enough flux in the paste. So that's good. I'm going to remove this guy. Okay. Oh, what's going on here? I don't know if I can reach that. Come on, hold on. There, it's gone. Okay. I don't see any glaring issues. Does any of you? Yeah, this one... Sorry. This one could be nicer, but it'll work. Cool. Okay. So we don't need the microscope anymore. So then let's solder on some connectors and test it out. Let's, nope. There. Super digital zoom off. Exactly. Let's remove this wire. And let's get some screw terminals. I think these will do. Oh no. Okay. I need to make a 4-1. The diff solo will work with any board really. So it'll work with an older DIG Quad 2, that's fine. It just needs to provide the data signal and, you know, that it will do. Okay. So we've got all the, let's see if we have all the holes on the right, oh no, on the right side. Okay, I think we have all the holes on the right side. Yeah. So let's do our onderzetter truc. Hoppakee. And let's solder the positive lead of each one. And then we can check orientation and fix it a little bit if needed. I need this guy. Okay. We need some solder. There. I'm using nice leaded solder. Sorry for the noise. I don't want to die yet. Oh, okay. We can use a bigger tip. Yeah, that's nice. It's a bit bigger. Soldering iron set to 380. Okay. Leaded solder for the win, exactly. Let's see how well these are now on there. Because we can still twist them a little bit and see if they're flat. But that's looking pretty good overall. These might need a little bit of convincing. Yeah, it's pretty good. Of course that's not on screen. Yeah. So then I always like to touch up the initial ones. Okay. Okay. Let's check that real quick. Where's my focusing area? There. A little bit much solder on some of the pins, but yeah, that will be fine. It's a bit dark, isn't it? There. No, it's less dark. It wasn't perfect. Some had too much, some had maybe slightly too little, but these are only for like 1 amp or something like that max. So it'll hardly matter. That's not okay. The hot plate is in the same cupboard, so the wire shouldn't be touching. Okay, are we ready to do some testing? Let's get a multimeter on screen. And we'll do some initial testing. In the end, I'll be scoping and doing all kinds of stuff with it, but there. Well, these aren't too big. These are 5.08 millimeter. Still got one twisted. Okay. So they're not huge, but they're not small either. I mean, they're just normal size. Should do okay. So, we don't need the fire brigade, but we do need some safety glasses, courtesy of Draadstaal. There. And of course we still have this can of Fire Stop, which has been here for years, so I'm sure it's still fine. Okay, let's get the variable power supply. I should also wear a hat, but I don't have a hat. Oh, okay, we'll wait, Pepsi, don't worry. There. So I guess we start with the buck circuit, right? And I should have labeled these. I did. Oh, that's not bad. I did not get a DEFCON 1 hat, no. So we're going to use these forks because that's what I have on my benchtop power supply. But I mean, once it's screwed in, that's pretty secure, and the way the board is laid out, it's not going to touch anything else. Okay, see, these don't really move anymore, so that's good. That's good. Are we 60 FPS? Yes, good. Okay. Multimeters. Let's turn this on. Let's go 12 volt, 1 amp. Sure. Well, let's go 0.5 amp. There. Okay. Let's put the... and as it says here on the board, this one is supposed to deliver 3.3 volts. So let's see if it does that. Let me refocus it. And applying power now. It seems to do it, but it's not stable. Or maybe that was my probes. Could be my probes. Hold on. Let's screw in my probes. Okay, that's better. Although it doesn't seem very stable, does it? Now, there's no load. So, I mean... some circuits aren't perfectly stable with no load. But let's turn it off. The power supply is off. Okay, it took a little bit. Okay, let's turn it on again. It's not perfectly stable in the millivolts. But that's something for a scope to figure out. So, I mean, yeah. And as I said, there's currently no load on there, which is not a realistic scenario. And some regulators just don't do well with no load. So that's not inherently a problem. But let's change the voltage from 12 volt to 5 volt. Oh. No, doesn't like that. Okay, let's go to 6 volt. Not stable. Let's go to 7 volt. Okay, so it needs 7 volt to make 3.3 volt. That's a bit unexpected. Okay. Is something getting hot? Let's see if something is getting hot. Well, no, this is a buck circuit, so it always needs a higher voltage, but it's a bit more voltage than I would expect. Let's see if we have anything warm. No, nothing warm. Well, there's no load, so, I mean, Okay, but I built this for high voltages, so let's go to 36 volts. Okay, that's fine. No problem. Okay, let's go to 48 volts. Yep, no problem. Let's see if anything's getting warm. Nope, nothing is getting warm at all. Well, again, there's no load. Should we generate some load? I guess we should generate some load, huh? Let's turn this off, set it back to 12 volt, and get a load generator. Okay, yeah, that's fine. So we need to unscrew this. We need to undo these. Let's see, plus. Okay, then we need some power. Turn on the power. Ugh. I mean, these cables should be able to handle 1 amp, I think. Maybe. Close. So 12 volt, let's set it to 1 amp in. Okay. We get a nice 3.3 volts. Let's load it down with half an amp. Okay. Drops a little bit. Let's see on the terminals. A 3.25 in the terminals, so a little bit of drop. Let's check the heat. Yeah, we're getting some temperature now, but the highest temperature we're seeing is 38 degrees. So, I mean, that's nothing. Okay, let's go to 700 milliamp. So, the thing that's getting warmest, I think it's the inductor. Which could be correct. The inductor is about rated for 1 amp. So, and it's still, I mean, it's 47.6. And it's currently 24.5 degrees here. So that's a rise of 20 degrees. That's not horrible. Now, in theory, it should be able to do 1 amp. So let's go to 1 amp. We're still at 3.23. That's acceptable. It's a little bit of drop, but... So the chip itself is also getting warm. Chip is getting 55 degrees. $56. $55. Yeah, but it's handling that. 62 degrees is not horrible. Over here there's a slight temperature spike, but it's only 41 degrees, and that is on the diode, which is to be expected. That's fine. Okay, let's go down to 0.5 amp, and let's start lowering the voltage and see when it craps out. So we're at 12 volt now. 11, 10, 9, 8, 7. It's still stable. 6, 5. Oh, okay, 5 it can't handle. That's too, for some reason that's too much. Now I want to measure some points. Yeah, we're getting 5 volt here. We're getting 4.9 volt after the fuse. Then on the diode we're getting 4.9, but after the diode we're getting 4.56, and here you can see the problem. So the input voltage for the regulator, because then it has to go through an inductor, which then goes to here. Oh wait, this is ground. No, this is not ground. I need to measure here. Yeah, here we still have 4.5, but then it has to go through this resistor. And after that resistor, it's 4.1. And even with 5 volt coming in, after the fuse and the inductor and the resistor, we're only left with 4.1. So let's measure this cap. Yeah, 4.11 volt that is going into the buck regulator that has to make 3 volt. And that is too low. It needs about 1 to 1.5 volt higher than what its output is meant to be. So that is a part of the circuit. So I could design some of those things away and make it less, but those are protection features and other things. So, you know, maybe I need a different circuit. That's why I test these things. Because on the output side here, nope, here, yeah, we're getting 3, yeah. So if I make it 6 volts, we get a 3.2 out. And now if I measure here, the buck converter is getting 5.2 volt in, and that's enough for it to make the 3.3 volt. Right? 3.26. I could play with the resistors a little bit and make that a nice 3.3 volt, but 3.26 is pretty close. Okay, so, you know, it's not suitable for 5 volt, but if we go there, 48 volt, we still get a nice 3.8287. So I could adjust the resistors again to make that 3.31 or 3.32, just to have to change the values just ever so slightly. And now we're getting 48 volt in. After the fuse, it's 47.995 because the amount of amps is very low now. Then we have a diode. That's 47.9, and after the diode, it's 47.7, so that's already dropping a few volts. Then it goes to an inductor and a resistor. We end up at 47.68, and then here, yeah, what is actually going into the regulator is 47.68. And then on the output, we have a nice, stable 3.3 volts. Yeah, okay, sure, that's fine. So that is kind of working as expected. It's just, you know, not making a great... it can't do it at 5 volt. It needs at least 6 volt. But that's good to know. Let's see if we can do... let's turn that back on. Let's see the temperatures. Let's go for 1 amp at 48 volt in. Turn it on. There. Okay, we're getting a stable output. That's good. Let's see how warm things are getting. Okay, now the chip. The chip is the one that's warmest. So the chip is having to work harder. How warm is the inductor? The inductor is 68 degrees. Okay. And the output... What's this? I think that's the output diode. Yeah, the output diode's also working hard. So this is slightly warm, but not horrible. And likely if we lower the voltage to, let's say, 24 volts. Yeah, the controller temperature goes down. It's now 60 degrees. And remember, it's doing a full amp of output. So, yeah. Pretty good, pretty good. Okay. Let's turn that off. Let's turn this off. And let's move to the next circuit. So this one is working, but because of all the measures I've put in place, it's not able to handle 5 volt in and making it 3.3 volt. It needs at least 6 volts. But looking at it like this, that's kind of to be expected. So let's set this back to 12 volt there. Okay, let's screw this in here. And measuring like this, we can't really tell too much in the end. I'll have to scope everything and see the differences and, you know, change some parts. In a few years we'll get Quinn motherboard. Who knows? Oh no, okay, well, we'll screw it in like this. Good enough. Okay, so let's start with 12 volt 1 amp. Okay. Yeah, we're getting a nice 3.334 or 33 whatever, 3.34. Good. Let's see what the multimeter says. Yeah. That looks good. Okay, let's start with 300 milliamp. Okay. It's not really exciting, huh? Let's see if something's getting warm. Oh, a little bit. So, yes, it should have short circuit protection on the output. So this is good. So that's the chip itself. It's getting 38 degrees. Now, this one should be special. So let's set the voltage to 5 volt. And now it's still able to output 3.3 volt. Although we have the same protections in place, because this is a different circuit. So before the fuse, 5.99, 4.99, 4.93. Let's see, after the diode, 4.6, after the resistor, 4.3. Oh. Yeah, okay, so 4.3 volt is going into the chip, but we're getting a nice stable 3.3 volt out. So let's see how far we can go. 4.9, 4.8, 4.7, 4.6, 4.5, 4.4, 4.3, oh, 4.2, 4.1, 4 volt, 3.9, 3.8. Oh, okay, now it's too low. So with 3.8 volt in, it's still able to produce... No, okay, that's not stable. 3.9. Okay, let's see what we're actually putting into the chip. Oh, other way around. Oh. So we're actually only inputting 2.9, but it's still able to make 3.3 volt over it. And after that, I think we're going into ultra low voltage protection mode. So this is a buck converter, so it can only down convert. But this is a SEPIC converter, so it can boost or buck convert. So currently we're giving it 3.9 volts, and it's making 3.3, although it's actually getting 2.9 in. But I can also now say, let's go 12 volt in. Boom. Still works. Sorry. And I should be able to say, okay, let's go 48 volt in. Might explode. No, perfectly fine. Still 3.3 volts. So basically this circuit is able to handle 3.3 volt in up to 48 volt in, and it'll always make 3.3 volt out. But because of the protections with the fuse and the filtering and the resistor and things like that, it can only handle a little bit less because there's a lot of voltage drop in the incoming circuit, basically, right? So let's go to 1 amp, see if it can handle that. So now let's see, is that the chip? Yeah, that's the chip. The chip's getting kind of toasty at 86 degrees. Exactly, Joey. So the input can be about 2.9 volts, but that is because of the protections in place. Otherwise, we could probably input about 2.5 volts and it would still be able to make 3.3 volts. But the chance that you're going to need that in a circuit is rather low. The things I generally want to build is 5 volt to 48 volt. My current circuits are all 5 volt to 24 volt. And these are new circuits to try and test and measure and things like that for 48 volt compatible boards, basically. So with 1 amp output at 3.3 volt, it is stable, but the controller chip is getting 90 degrees. And let's see how warm, what is that? Let's see, what is that? So we have an inductor that is 73, and we have a diode, but diodes always get warm, so that's fine. That's 67. That's okay. Yeah, that's a bit warm. That's a bit on the warm side. But if we go, okay, but we only need half an amp. Okay, if we only need half an amp, the controller temperature quickly goes down. Okay. 300 milliamp. Now, remember, we're still at 48 volt in, and we're getting 3.3 volt out. That's a massive, over 15-fold difference. So that is challenging for these chips. So let's say we want 12 volt in and 3.3 volt out. Let's see what that does with the temperatures. It drops nicely. Yeah, so a SEPA converter is a different form of a boost converter, or I guess you could call it a boost buck converter also. But yeah. But it has its own challenges in design, especially if you want to conform to EMI and EMC and stuff like that. So with 300 milliamp out and 12 volt in, our temperatures are settling down nicely. Nice. So we're going to move to the next circuit, but we're likely not going to see much difference, if at all. Because for those differences, you'd have to take out the scope and use a realistic load and things like that. Let's go to this one. No, can I make... No, okay, I can't really get this to work, so we'll move on to the last one. Okay. Last circuit, 12 volt, 1 amp in. It's also generating 3.3 volts. Good. Very good. Let's give it a load. That's fine. So what's heating up? That is the controller, I think. And the output diode, but that's both to be expected. A little bit. 12 volt in. Okay, let's go to half an amp out. So let's go to 5 volt. Okay, that heats up the resistor. That's to be expected. Oh, we're current limited? Why are we current limited? Hold on. Okay. Wait, what's going on? That's not good. Something got very hot. Okay, let's try that again. We're at 5 volt, 2 amp. Let's turn it on. Okay, 3.3 volt. Let's do 100 milliamp. 300. Okay, let's do some measurements here, because I'm not sure this is working correctly. So we're getting 5 volts. 4.93, okay. 4.6. Okay, 4.3, is that correct? Yeah, we're getting 4.3 volts in, but it's having to make 3. Okay. Let's go to half an amp. Whoa, see that? Let's not go to half an amp. What is going on? $400 milliamp. $400 milliamp still fine. 500 milliamp. What the? Yeah, that's toasty. Okay, so I want to measure what happens when I do that on the input capacitors. So we're at 4.3. If I up the load, oh, we're at 4. Ah, okay, the voltage sags too much. So that's the problem. But why does it sag too much? So we need to measure the voltage going into the circuit. So currently with 200 milliamp. Oh wait, hold on. Okay, currently with 200 milliamp, we're at 4.96 at the fuse. With 300, we're at 4.93 at the fuse. With 500, we're at 400, we're at 4.89, and here we're dropping a lot of voltage for some reason. Let's go to the diode. 4.6, 4.5, 4.3, okay. Then let's go to the resistor. 4.3, 4. Ah, okay, 3.1. Okay, so of all the components in the circuit, the resistor is starting to be too resistive, basically. And it's causing a problem where it's drawing too much amps through that resistor, and thus it's heating up, and thus, the voltage sags a lot. So let's go to 12 volt, and that will likely solve all the problems, because then the voltage sag won't be that much. So 300 milliamps. Okay. 400 milliamps, 500 milliamps. Nothing really happens. So now we're at 12 volt in and not at 5 volt in. So this system, yeah, we're now at 1147 after the resistor, so that's fine for this circuit. So this resistor is basically too limiting on the input side, and because of that the voltage sags too low, and then the boost converter tries boosting that up, but that's a lot of work, so it overheats. Just like the inductors and things like that. Okay, so let's see if we can draw 1 amp of 12 volt in. Okay, 1 amp. This inductor is getting a bit warm, and this diode also, but that's expected from the diode. Okay, sure. 73 is on the warm side, but we're drawing 1 amp. Let's change the voltage. VSET 48. Let's go. Boom. Yeah, so if a higher voltage coming in, the chip needs to work harder. Just like this inductor. Okay, so let's go VSET 7 volt. And you can see with 7 volt that this resistor is starting to heat. Oh, okay. This resistor here starting to heat up. Because now the amount of amps that go through it is a lot higher, right? Okay, and our chip is at 100 degrees again. Okay. So, likely if we go to 8 volt... Oh, not much different. 12 volt? Yeah, okay. 12 volt, it cools down. So, this resistor is a bit too limiting, I'd say. Right? Now, last thing we'll do today is see if we can fix that by using a different resistor. So, let's go to 250 milliohm instead of 1 ohm. No, let's go to half. Sorry. Half an ohm. Now, this is all experimental, and having these resistors in there is also experimental. Okay, tweezers. I'm not sure I can do that on camera. I don't think so. Because my hot air station doesn't reach that far. Oh, let me turn on my hot air station. There. Let's make sure I can grab it. Okay. Set to 200 degrees. That should be fine. Still can't see it. It's taking a while. Okay, I've got it off. Let me put the other one in its place. Yeah, but it's already done, so. Exactly. So I replaced this guy over here. So this guy's gone now, and it's half an ohm instead of an ohm. And let's see if that makes a difference. Should. Let's zoom out. I have to wait a little bit because now everything is really warm. While it's doing that, I should be able to set up my screen sharing. Let's see. There. I guess I need to move everything a little bit. Okay, so everything's still warm, so I need to blow on it a bit. There. That helps. I'm gonna take these off. Okay. They hurt my ears. Okay, good enough. Let's go to half an amp. And we're still at 12 volt. Let's first turn it on. Okay, still works. Oh, it immediately starts storing power. That's fine. Okay, but we're at 12 volt now, so let's go to 7 volt, which was a problem before. Okay, the diode of the resistors are heating up slightly. Let's go to 1 amp. You can see the resistor heating up. Oh, we're at 100 degrees again. So then, what is the voltage? Oh. That it's getting at the input. 6 volt. Huh. You'd say that'd be enough to generate 3.3 volt. But I guess it's not. Or maybe it's just not getting the amps it needs. Yep, it's a bit warm. Oh well. Anyway, that is, I think, going to be the end of the stream. I guess you guys want a secret too, huh? I didn't think of one. Uh-oh. What do you guys think of such a stream where we build a board and test it a little bit? I think, you know, for people who are interested in that, I guess it's interesting. but for another half, I'm not sure, what you get out of it, unless you just like seeing me build and suffer. But I like doing it on stream, because it's nice to start with nothing and finish with something, and hopefully it works. And so far, this is working pretty well. This is a test board, so it's meant to have components that I'll be replacing, like the resistors and things like that, to test it out, see how it reacts, see how it changes before I use one of these circuits for real on a production board, basically. Yeah, secret. Well, something I haven't announced yet, so that's good. If you order a Dig Octa right now from Allnet, or in a week or so from Dr. Z's, you'll be getting a Brainboard V2, which has some slight changes and things like that. And one of the changes is that it's possible now to use audio reactive, so a digital microphone, on the new V2 Brainboard. Yeah, exactly. I mean, I like doing that with you guys, so... But I also like having varied streams, so yeah. Yeah, so I made some changes. Internally, it changed a bit more. I rerouted a bunch of stuff, and there's some other changes on there. But user-wise, there's not much that you're going to notice from that. Another change that happened is that the temperature sensor on the board is gone, but there's now a socket for a I2C temperature sensor that I'll be releasing soon. That will also fit on, for instance, all the new analog boards and other boards going forward. So that's also a change. Thinking what else changed that you might notice. Yeah, it's more circuitry layout and regulatory stuff, things like that. So the extra pins that are now available for instance, audio reactive, that is a big one, I think. And also that the temperature sensor moved off board, which I also basically frees up those pins to use for something else if you wanted to. Those are the biggest changes you'll notice, I think. Oh, okay. Thanks, Iman. That's a good point. Although I don't really do much explanation of how I built the circuit, and I kind of don't show it also, because I got reminded again this week, I helped somebody out improving his circuit, and now he's going to sell it commercially. I always feel a little bit screwed when that happens. So that's kind of why I don't show schematics or layouts on the boards themselves. Maybe we'll do a series on that in the future. I don't know yet. But, I've had bad experiences with that. I do like building them on stream with you guys, though, and testing them and see if they work. And, yeah. Maybe you'll see this back in the product. Maybe you won't. Yeah, really depends. Dig Uno and Dig Quad are, for now, staying as they are. They had some small updates a while back. Again, mostly circuitry and layout changes. But nothing really the user will notice. So I do update the revision history and things like that. But I don't make big announcements about that mostly if it's not a usability change, basically. There's other boards that are certainly coming. The AN Penta Plus should be releasing soonish. The AN Penta Deca will release after that. There is the Power 5 HV. So that's a high voltage version of the Power 5 that will do up to 48 volt support. And, there's a few things coming in the pipeline. You need a dig to go with 2 channels. Okay. Oh, are you leaning one way or other for the RGBW cob? I am working towards getting that done. I'm not sure when. We're working on it. I got some new samples. There was some stuff that I wanted changed on that. So we're discussing with them, and also pricing is a big point, of course. But I'm working on trying to get that done. I'd really like to release those because, they do a lot of stuff better than what's currently on the market. So, yeah. Yeah, so that's the problem, Joey. A dig-to-go with USB-C will never be able to handle 24 volt because USB-C is 20 volt max, and 20 volt is not enough for 24 volt strip. Yes, there is 48 volt USB-C PD now, but chargers for that they're not affordable at all, and the chips to do that aren't either. So that's a few years out, and then you're left with 12 volt and 5 volt. But 12 volt isn't as useful as you think, because if you then want WS2815, it's better to use 5 volt because then you get more light and more LEDs. So then you're left with cob strip that you could use at 12 volt. But so the usability for that is low. I will investigate it at some point and probably build a revised or an updated version of the dig-to-go that does all that stuff, but I'm not sure when. Yeah, Iman, those strips are going to be awesome. I did some more testing yesterday. Whew, they're very nice. They're they're very nice. Anyway, diff power. I'm also working on behind the scenes. It's a bit slower than it was before because there's other projects that need finishing. Basically, it's better to release some stuff than have 10 things that are unreleased and I'm working on. So at some point, I need to work on releasing them. And then I can get back to development again. So, yeah. So I don't have any secret things to show you. Well, I guess I could show you the latest diff power. It's on my desk. Let's see here. So this is the latest diff power receiver. So the... oh, wait, you don't see anything. Oh, no, don't do that. Let's go away. There. So this is the receiver medium, and then you have this buck converter you fold on there with stands, and that will do about 6 amps, it says, for 5 volt. This basically works. It needs some small changes, and you can see I edited some stuff here, and the circuit basically is good now, but it needs tuning, and we have the sender 1, which I'm implementing all my changes on right now, and that is also basically working, although you can see I've been mangling it about, but that needs the most tuning right now to work correctly, but we're getting there, and yeah, at some point we'll be there. So, Iman, I'm hoping to get that done in like a month or so. Right? Don't pin me down on that. And it depends on how long the manufacturing takes and then how long it takes for us to get it to market and things like that. But I'm trying to get that done sooner than later. But I'm just constrained by how fast we can move in that regard. Yeah. Yeah, those bamboo printers are fast, Draadstaal. I really love my X1C Carbon. It's helping me a lot, actually, prototyping cases and face plates and things like that. Cool, Jeremy, thanks. Thanks, Monty. That's appreciated. Yeah, the new strip. I guess I can show you. Need to see if there's branding on this one already. I don't think so. Hold on. One moment. No, I believe these samples are okay. So, these are the new strips. This is a non-waterproof version of it. And yeah, they're still very nice. But we're not going to talk about them too much today, because people will steal the ideas. I love my X1C Carbon. Yeah. Oh, Bumble with AMS. Yeah, I also have an AMS. And I've been printing in PETG, and I've been printing in PLA for normal prototyping and stuff like that. And for generating, I don't have one on my desk, but like those cases when I'm working on the prototypes, or when I'm working on even the face plates for the upcoming analog boards, I can 3D print them, and even 3D print the PCB as it's going to be, if I get all my 3D models right, stuff like that. And then I can actually fit them together and see if it's going to work or not. And generally it's pretty close, and then only needs some slight adjustments, and then we're there, instead of just guessing and paper cutouts and things like that. So yeah, 3D printing is really nice. Sure, I get that. I mean, I use it for work, Drahtstahl, so you know. But the A1 also seems very nice to me. From what I've seen from it, it works really well. Is the heart still working in the chat? Oh, it is. Nice. P1S. Oh, nice, Phil. Yeah, it's basically the same machine, so. I also like to print ABS and some other materials sometimes, so yeah. Yeah, they made a big one. Who knows? I'm pretty sure they're working on that. I do not have such issues, so. But I printed something for on top, which moves the glass up, and then I have vents on all sides, which I can open and close depending on the material I'm printing, and then it's fine. So, or you just leave the door open. But how much does a 24-volt cob draw again? The version I am working on can draw a lot, but that's because it's really bright. Let's just say it might be the brightest strip that you could buy right now. I'm not going to share by how much. Yeah, I had an Ender 3 modified, new main board, rewired, blah blah blah. I was so tired of messing with it. I bought the bamboo, I put the Ender in a corner, it's still there. Never touched it again. I mean, price-wise, they're very different. But then again, if you compare it with an A1, it's not, you know. So the top I have with the vents for the X1C also has an LED strip all around that I'm controlling with an AN Penta Mini. And it's linked through Home Assistant, so as soon as the prints start, it lights up in pure white, or 4300 Kelvin, basically. And then once the print is done, it lights up in 2700 Kelvin, because I have a CCT strip in there. And that's automated through Home Assistant. And then the lights stay on for another hour, so I can get the print out. And, yeah. We can talk about it on the Discord server, Iman, if you're there. But just be warned, these won't be cheap. I mean, they can easily be twice as much as the next variant, basically. So, yeah. Then again, the next variant has 10 centimeter zones, so... No, so when it's doing its scanning, I think I set it to turn the lights off. I have to look at the automation. But you can, in Home Assistant, you can see all the various stages. And you could say that once it starts LiDAR scanning, to turn off all the lights and then turn them on again. Okay, well, we should be able to hit that target, I think. Depends a little bit on tax and things like that in your country, but yeah. Okay, well, we've been streaming for 3 hours and 11 minutes, so I'm going to call it here. Thank you all for being here and watching and keeping me company while I build a testing board. We'll see what comes out of it in the future, and I hope to see you back in the next video, live stream, in the comments or on the Discord server. Thanks for watching, guys. Bye-bye.